Hello students, it's me again, Professor Childers. Today we're going to be discussing pneumatics. What are pneumatics? Pneumatics are a device that we use to control or to move objects. Now we have two types of fluid power systems that we talk about in this class. One of them is hydraulics, one of them is pneumatics. Okay, pneumatics uses air. Hydraulics uses oil. Okay, now with pneumatics you have an open system, which means that we use air as our source to move our objects. And we have two types of motion that we use. We have linear motion, which is a cylinder that moves in and out, and we have rotary motion, which is a motor that rotates. We have both of these in both hydraulic and pneumatics. Now, pneumatics is a closed system, and basically what that means is that you have a reservoir tank, and the oil, or the hydraulic oil, is constantly circulating throughout the system. For many of you that are car enthusiasts, you know, you like to put lifts on your cars to lift them up. Okay, pneumatics are really easy because all you need is a compressor and an air tank. Okay, and your source is all around you. You breathe it every day. However, with hydraulics, you have to have a tank and a reservoir, and that gets to be a little heavy sometimes. So, you know, if you're going to put hydraulics on something, you need to put it on something really heavy like a truck. If you're going to do something with your vehicle, you want to do airbags. Now, pneumatics are designed for speed. So, for example, if you've got something coming down a conveyor belt and you want to shift it to another conveyor belt, you would use a pneumatic cylinder for a pushing mechanism. Okay? Whereas hydraulics are designed for power. Okay, when you're out here on the freeway and you see all these excavators working, they're all hydraulic. These cranes are all hydraulic because they need that power. Okay, so that's kind of about where it's at. So what I'm going to do is I'm going to give you a little demonstration here of pneumatics. So on this board we have a pressure regulator and a gauge. Now, this regulates the incoming pressure to the system because you don't want to run 150 psi or pounds per square inch when you only need to run about 30. Okay, pneumatics run low pressures, and the difference between pneumatics and hydraulics is the lines that we use. This is a standard pneumatic line, and it's plastic tubing. Okay, whereas a hydraulic line is much heavier. And the hydraulic line basically is got different fittings on it, and it's a heavier braided hose. Now, this is an Amatrol trainer, and this is designed so that you can train on it. So today what I'm going to do is I'm going to show you basic pneumatic connection and what we're going to do with this. So you're going to take your first hose, and you're going to come out of your regulator, just like this. Get a different hose, this one doesn't want to work. So we come out of the regulator with a snap neck, and then we're going to go to a directional control valve. Now, a directional control valve basically takes the air or the source and changes direction of it. Okay, so we're coming out of our regulator to the input of our directional control valve. And then what we're going to do is we're going to take and grab another hose, and we're going to come out of one port of our directional control valve. Then we're going to go to our cylinder. We're going to take another line, and we're going to come out of our directional control valve. And we're going to go directly to this cylinder. Now, this is a dual action cylinder. What that means is that it takes air to move it both ways. Okay, so we're going to use air to extend the cylinder, and we're going to use air to retract the cylinder. Now here, this is a spring-loaded cylinder, and the piston is normally inside the cylinder housing until the air is applied to it, and then it extends. There's a spring in here. This is a single-acting air cylinder. This is a dual-acting air cylinder because we've got air going to both directions. So what we want to do is we want to safely turn the air on, and we want to open the valve, and then we hit the directional control valve, and the cylinder pops forward, and the cylinder retracts. How simple is that? Now, to what functionality this air cylinder has in our daily lives? Well, for example, I used a conveyor line. So you've got a package that's coming down the conveyor line and it's got to be shoved off to a different conveyor line. You will not have somebody standing here operating this valve. This will be an electric control valve, probably controlled by a PLC or a program logic control. So the package comes down, it's barcode read, and it shoots it all the way over and retracts. Okay, now, also, water valves for water resources can be controlled this way. And you always want to let the air out before you disconnect your lines. So that is linear motion. Okay, linear motion means extend and retract. Now we're going to go to rotary motion. And I'm going to connect the motor up to the directional control valve. If this will fit. Okay, well, it's not going to fit, so we're not going to connect that line. We're going to connect a different line. Some of these snap connectors are a little difficult and a little tricky to get in, and you really have to work at them sometimes. The one thing you definitely don't want to do is you want to make sure that that thing's tight, because you don't want an air line to break loose. That would be a bad thing. So we've got our snaps in, we're good. Now I'm going to apply a little air pressure, open the valve up, and we'll see what happens. Now I can control the speed of that by controlling the air pressure. So if I take the air pressure down, I can control the speed of the motor by the air pressure. Now, one thing that you need to understand is that air motors use a tremendous amount of air. And the problem with that is that you've got to be very careful in that to make sure that your compressor and your air source can cover that much air. Okay. Very rarely do we use air motors, only because of the fact that they do use a tremendous amount of air. So, with that, I'll finish up this video real quick. With that, in essence, what you have is you've got hydraulics and pneumatics. This was a pneumatic demonstration for you today. The one thing, again, you want to make sure of is that you wear safety glasses, which I didn't do. Second of all, make sure that all of your connections are tight, secure, and they don't come loose. Because an airline that breaks loose can be dangerous, it can hurt somebody. It's not a lot of pressure, but it can still hurt somebody. The other thing to remember is that airline fittings require white Teflon plumber's tape. You cannot use Teflon tape on hydraulic lines because the hydraulic fluid will deteriorate and destroy the tape. Hydraulic fittings also are tapered so that when you tighten them up, the more you tighten them, the tighter they get. Okay. Now, again, the difference between hydraulics and pneumatics is that pneumatics is built for speed, hydraulics are built for power. Okay? And with that, I'd like to say thank you very much and keep watching our videos.